professor of public policy in the Luskin School of Public Affairs here. His research centers on international and comparative politics. He uses a lot of social media data, which I think he'll describe to you today. In particular, study subnational conflict. And I'll hand it over to Zach. Thank you.
Thanks, Jenny. Yeah, so thanks, Jenny, for having me here. Thanks, Alina, Frito, and sorry, I'm forgetting your name, for organizing this. And thanks all of you for sticking around in the middle of the week, middle of the day. So this talk is not going to be programming. I'm not going to show you any programming or give you any code. I'm just going to talk about Twitter and then show you two of my main projects that use Twitter data. And then I want to talk about just some things I've learned in the past few years, kind of working in this space, especially what it's like to work with people with technical backgrounds, people outside the social sciences. So these are way too many dots. You should never have this many slides in a presentation, especially when you only have 75 minutes. So I will try to go kind of quickly through the text and images. A lot of those are just kind of graphic slides. And then feel free to interrupt me at any point with questions about a specific research issue I present, or if you have a question about programming or whatever. Let's keep this really casual. So I'm from all over. I lived in Texas when I was 14. Then my dad's job took us to the East Coast. My undergraduate majors were in anthropology and economics, but really anthropology. So at this point, I've kind of been studying humans for a long time. And then I drink too much coffee. But I like good coffee. So I got my PhD pretty recently from UC San Diego, and I like to study contentious politics. Is kind of the big phrase that lumps me in with civil war or riots, but really I study protests. And then in this bullet point I've said large and not just Twitter, because even though 90% of my work uses Twitter, I'm always looking for other data sets, and I'll show you one slide where I start to use some cell phone data as well. So to paraphrase Max Weber, right? He was talking about governing politics. I don't consider myself a super technical person. I've always been okay at math, but not great. I think I got through second semester calc in college and then statistics, etc. But never super deep in this stuff. And I've never taken a formal programming class. In my undergrad econometrics class, the professor had us. I wouldn't say learn R. He didn't teach us R, but he was like, "You're going to do your stuff in R." So I had one semester exposure to that. And then I got to grad school, and I saw the methods professors were using R. So I was like, okay, well, you should use R. I'm very bad at SCADA. No shame in that. And then in my third year, I picked up Python. So that's when I was writing my dissertation proposal. And then one of my advisors, James Fowler, paid for me to take a 1-week ICPSR summer course. It was called Large Scale Network Analysis using Python. It was like a half Python course, half network analysis, and that's when I picked up Python, and then I used those two kind of interchangeably depending on the task. For the longest time on Stack Overflow, I was user 187924, right? And I only have 300 rep points. I mean, so the point is simply, I'm not a power methodological user. I'm just someone who uses these tools for my research. So one thing that always comes up in this space is whether you use R or Python and which one is better. The answer is they're both great, and it kind of depends on the task that you're doing. But if I had to choose one, what do y'all think it would be? What do you think I'm going to say on this next slide?
Python.
Yeah. I still use R a lot, especially for visualization. Python is easier to read, and there's actually a lot more support for it because it's used in a kind of programming computer science space. There's just a lot deeper of a community there than for R, and a lot of tasks, especially the kind of stuff that y'all are learning in here, and that I'll show you is native to Python first, like computer vision type stuff, and then kind of sometimes it's ported over to R. So that's all just a long way to emphasize that I consider myself not a methodologist, but someone who studies contentious politics using computational methodologies. So, I don't have I have like a couple GitHub repositories, but I don't really know how to use GitHub. I don't have like packages I've written, stuff like that. So that's kind of my background. That's part of why, I'm not teaching programming in the 75 minutes because I probably don't know best practice. All right, so I want to talk a little bit about Twitter first. I'm sure we all basically know what it is, but it's good to kind of refresh ourselves. The Library of Congress struck an agreement with Twitter in about 2012, I think, to create a publicly accessible archive of every tweet ever. And the last time I checked in 2017, that was still a work in progress. So maybe one day we can all use these data for free, but right now it requires some sort of programmatic access and some sort of special knowledge. What's nice about Twitter, features that make Twitter nice for researchers are on this slide. It's very easy for people to create accounts, which means people who might be from sensitive populations, let's say, are not going to feel that they'll be more likely to sign up because they don't have to give an address or a name or race or anything like that. And we forget that it was actually designed for a world of dumb phones. It was really a text messaging service first. The reason I'm highlighting this is because that means you can use it in poorer countries where you have brick phones. I mean, now I think cheap Chinese Android phones are pretty widely available. But the point is, it's not just a smartphone-only device, and so you have pretty global coverage for quite a while now. People can follow other people and not be followed back, right? So it's not like Facebook where you have to both acknowledge each other. This, of course, is why it's become a very popular place for celebrities and elites and politicians and things like that. It has a norm of public production. The only real difference in terms of data availability between Twitter and Facebook is that most accounts on Twitter are public and most accounts on Facebook are private. So you cannot access data from private accounts on Twitter, just like on Facebook. It just so happens most accounts, about 90% of accounts on Twitter are public. And then it's best if you're interested in studying the spread of X, the spread of fads, the spread of protest information, as well as how people kind of interact with each other, the social grooming, right? You can mention people, you can kind of all use the same hashtags. You can see communities converge on hashtags. You can tweet people. There's a lot of nice large-scale human interaction that Twitter is set to facilitate, and because most accounts are public, we can therefore study. The historic API is called the REST API, Representational State Transfer, which is that's a common acronym. It's not a Twitter acronym. It's a streaming API, which you can connect to get information in real time. I copied this slide from my Arab Spring presentation. The tweets that I used for this text presentation are from Alex Vespignani. Actually, I think he was grandfathered into the 10% stream, and so he shared with me tweets from the Middle East and North Africa. So that's where my Arab Spring tweets come from. The streaming API gives you just 1% of tweets in real time, and you used to be able to pay for enhanced access to the 10%, and now Twitter doesn't sell that. The tweets are given to the streaming API based on whether the timestamp is like it's I think let's call it the 600 to 610th millisecond of every second. So that's how they randomly sample it. It's just this one particular moment of every second, the same moment of every second, those tweets get sent to the streaming API. Twitter used to say they had 320 million monthly active users. Their preferred metric now is monetizable users, I think they call it. That number, I'm actually not sure what that is, but it's much less than 320 million I'm sure many of these people are bots and not very active engagers with the service. Like I said, it's available everywhere because of its low barriers to entry. If you were to look at distribution of tweets and where accounts are from, it's essentially going to mirror like the world population map and nightlight map, right? Kind of like everything. It's certainly more prevalent in higher income countries, but as long as your time window is large enough, you can still get enough information from poorer or less populous countries. But basically, the more populous the country or the richer the country that you want to study, the more likely you are to be able to use Twitter. But the Gulf states, the UAE, Saudi Arabia, Twitter is incredibly popular. Philippines, you could use it very easily. Indonesia, Japan. So they're kind of these idiosyncratic countries where Twitter is incredibly widely shared. The statistic Twitter also told you is 500 million messages per day. I think that's actually gone down a little bit. It's probably close to 400, 450. But this is the number that they'll say publicly. And so that means that when I connect to the streaming API, I get 5 million tweets per day. About. I've noticed I'm getting more 4.2 million. That's why I think there are actually fewer than 500 million messages per day. And that number has gone down over the last 6 years. You cannot use it to study China. Because it is so easy to get access, it means that there are a lot of bad accounts, right? This is something that I don't think we really appreciated in America until the 2016 election. But it also means if you want to understand how women or men tweet about a protest, or how they engage differently, or how religious affiliation might change how you express yourself on Twitter. It's going to be very difficult to do that, right? There are whole bodies of research in computer science about how we can get metadata on accounts based on the time of day that they tweet, or you read the text of the tweets to try to understand where they are. If their screen names are their real names, like on Zacharys, well, names are pretty gendered, so you can try to back out gender that way. But just from the account itself, you essentially know nothing about who or what is controlling it. You know when it was created, you know how many followers they have, you know a lot of Twitter stuff, but you don't know about the entity behind the account. There are a fair amount of bots on Twitter. There's this service called, used to be called Bot or Not, now it's called Botometer, run out of Indiana University, and the guy who created it's actually at USC now. That will give you a bot score for an account that you give it. So this is fine. Presumably there are really good bots out there, that governments run that this isn't going to detect, but you can go to services now to kind of eliminate bots from your data. I have found though that bots do not appear to geotag their tweets, or only the really good bots do, I guess. But I have one paper where we've looked at the Euromaidan protests in Ukraine, and there were few enough tweets that we had Ukrainian coders just look at these accounts and Google them and try to figure out this extra information about the account, and they felt like there were very few accounts that were bots. We found maybe 1 or 2% of our accounts appeared to be bots. And then using Botometer for this image work, I found it varies a little bit by country, but 2 to 6% of tweets were from bots. So at least for geolocated stuff, it doesn't really change anything. And
Yeah, can you give a little background on what observables you would suspect to be different on bots versus non-bots? So how do you even find out?
So bots tend to follow a lot of other bots, especially if you followed by other bots. So they tend to be in kind of their own part of the network. Bots primarily are they're not really trolls because it's kind of hard to kind of mimic human language. They're message amplification. So they're really just trying to follow other people that are also bandwagoning on whatever the popular topic is. So they tend to be in these very specific communities actually, and so Botometer will look at their follower list. I'm not sure exactly what they do to the follower list because you can't crawl the network enough to get a huge like a global picture of the bots network. They're also going to tweet with a lot of hashtags and links. So before Botometer existed, when I was doing the Arab Spring work, the kind of standard practice was if there are like 3 hashtags and a link in a tweet, just throw it out. Because more likely than not, that's someone who's trying to not really engage in whatever the hashtag suggests they're about. They're just glomming onto some trend. So it's who they follow and then proclivity to use hashtags.
So you throw out all the official accounts too, right? Because usually you would have many hashtags and kind of like links on like faculties or any sort of like official accounts that want to advertise something.
If you were to just use the heuristic number of hashtags and the link, that could throw stuff out. Yeah.
I was wondering how in authoritarian countries you deal with what Timur Karan calls preference falsification. Like, is that something that can be concerned?
Yeah, that's a good question. So when I was doing Arab Spring work, I just assumed it wasn't much of an issue because we had a lot of evidence that these countries just didn't really think of social media as a threat. So there wasn't really, I don't think there was really preference falsification then. It turns out that when it used to be until mid-2014, no matter the level of geographic aggregation you assign to your tweet, so as a user you have to opt into geotagging, and then you're given like that little pin, and you can say Syria or Los Angeles or Westwood. Regardless of how aggregated you went, whether you said country or like your specific street corner, through the API, Twitter would actually provide the precise GPS coordinates. So it was really bad. But the point is, in that case, I think before 2014, people were probably not engaged in preference falsification because they didn't think that they could be traced so precisely to what they were saying. Now, my work specifically, because I'm looking at like, my work is always like once you have protests happening. Like I'm not trying to predict protests. I'm saying there's protests going on. People are in the streets. Like what are we seeing? I think that's when true preferences have been revealed, right? That's when we know what private preferences are. So that doesn't bias my results. I don't think preference falsification biases my results. But sure, if you're trying to measure like public opinion in Saudi Arabia, for example, I don't think you could use Twitter for that. I think that's a real concern. Yeah. Then you also now have basically like troll accounts which trying to give you a false impression of the population's true preferences, right? So Andrew Little has a paper on information technology and protest that makes this point. And then tweets are very short, so it's hard to get complicated information in the tweet. But that's kind of made up for the volume of tweets that we have. So I think Twitter's going to be around for a while. For better or worse, the candidate and then President Trump have been good for the platform, for the relevance of the platform, and I think have made, especially a lot of skeptical audiences, academic audiences believe in it as something worth studying and paying attention to. A lot of the problems on this previous slide are also not unique to Twitter. It's kind of just the online space, and as researchers we need to know how these could bias our data, how we can clean our data, but bots, trolling behavior, that's not unique to Twitter. And it only has really one competitor. This guy, Khaled Litaru, has a lot of work on a whole bunch of kind of big data stuff, and he has some more critical takes on Twitter, so you can click on this link, and it's his blog with search results for Twitter if you want to see some less optimistic interpretations of Twitter. His basic point is that over the years, Twitter has become more and more dominated by elites and kind of like retweeting and broadcast behavior, not normal everyday interaction like it used to be 2008, 9, 10, 11, that sort of thing. All right, so for the next maybe 30 minutes or so, I'll go through these two kind of large research programs that I did. So this is my job market paper. This was the main paper from my dissertation. And it was motivated by the Arab Spring and the fact, so I started grad school in 2010, so this happened spring of my first quarter. but I didn't start researching this until late 2013. But we all think of it in Egypt, the first big protests were on January 25th, and those weren't the first big protests, but there was actually a call to protest for January 18th. So the call went out, like a week before the 18th, and said, everybody, let's go to Tahrir, protest, and because the Tunisians could do it, we could do it. This is our moment to change things. And it was just a few activists and a few dozen riot police. There's maybe no news coverage, but if you read like anthropological accounts of people who are on the ground, like that's how I know this existed. And there was a YouTube video that called people to protest for January 18th. So the question is, why do we see big protests a week after when there was actually the first protest? And so to study this, I take advantage of two then new sets of data, both text-based. So to measure the number of protests, I relied on these two data sets. These are different data sets, but they do the same thing, which is read newspapers. The computers read newspapers. They have dictionaries and programming rules to extract events from newspaper articles. It's the first few sentences of articles, I believe, not the whole newspaper article. And then they create data from that article. And the data are structured such that you have Actor 1 doing something to Actor 2, and there are 20 categories of action. There are 20 event types that you could have. There are sub-event types under that, but 20 main ones, and one of those is protest. So I went to this data set. I first started with GDOT. Some issues were raised about it, and so IQs came out soon after that, and I switched to IQs. They give you the same results. I think kind of the concerns about this were a little misplaced, but that's a different story. So machine-based reading of newspaper text, and then to measure what people were doing, I turned to tweets. 13.8 million tweets I alluded to on this earlier slide. And they were all at the country level. We wanted to use tweets with just GPS coordinates, but we couldn't get enough, so to go down to the city level. But if you trust people's self-reported location, which is generally pretty good, you get enough tweets, and so we aggregate to the country level. And so I go into some network theory to try to explain why we saw January 25th happen on January 25th and not on January 18th. And the key insight is from this work really started, or I'd say popularized by Damon Centola, which is that there are some types of fads, of contagions, of events, where what matters is not that you know about it or even that you have repeated exposure to it, but that you have exposure from different sources. Other kinds of events, it doesn't matter if you're exposed to it from one person multiple times or multiple people one time. It has the same effect. Those are simple contagion events. Complex contagion is when you need the multiple exposures. So like a simple mobilization, a simple contagion is like catching a disease, catching something communicable. If a sick person, someone with a cold, sneezes on me 5 times, that should have the same probability of causing me to get a cold as if 5 different people each sneezed on me once. On the other hand, if a protester, texted me 5 times a day or tweeted 5 times a day that, hey, you really should come out, here's where we're meeting, there aren't police here, or whatever they're going to tell me, that one person telling me 5 times doesn't give me as much information as 5 people telling me 1 time. An event like protest or like adopting maybe some new fashion like fanny packs, you're going to need to see a lot. I know, right? You need to see a lot of people doing it to know that there's like this safety in numbers essentially. And different people are going to have different thresholds. Some people, like someone has to wear the fanny pack 3 years ago, right? But then when everyone in your neighborhood is wearing it, some of those people waited for 50% of people to wear a fanny pack. And so complex contagions assume that people have thresholds of participation, of seeing other people, some X percentage of other people participate before you yourself participate. And so the point that I lay out in this paper is that protest is a complex mobilization event, and the January 18th, the call to protest on January 18th was propagated by an elite activist who essentially was only one person, and it was not really a strong signal to bystanders that there'd be a lot of other bystanders also participating. Whereas on January 25th, actually, it was a much more peripheral-led event. Yeah?
So you mentioned that you started this project around 2 years after the event. Did
Yeah.
you have the data, were you already collecting the data in real time as the event was happening, or were you doing it retrospectively?
Good question. Yeah, so Alex Vespugnani was collecting the data in real time. Yeah, so I emailed him in 2013. He provided me the data from real time. And actually, all the tweets that I collect are in real time for a couple reasons. One, to get data in retrospect, you're then often like looking on hashtags or keywords, and that's going to bias your sample. It's like selecting on the dependent variable. And then there's often tweet rot, right? Like tweets go private or accounts are deleted, and if you try to go back a year or two after event, you're not going to understand what the information environment was like at that time. So I collect tweets in real time, and I think that's best practice. I'll go back to the REST API for other information. I've never gone back to get old tweets, but to get account metadata. But you could, and there are people who do that. The search endpoint of the REST API at its base level, I think, only goes back 7 days. They may have increased it to 30 days, but the point is, even if you're not connected to the streaming API and you want old tweets, you still have to be very on top of your game if you're responding to some sort of event. And so at that point, I think it's actually more stressful to try to get tweets from the REST API than to just always be collecting from the streaming API. You can pass keywords to the streaming API so that Twitter will only give you tweets containing those keywords. So you can zoom in on a question you're interested in, like if you want to study, racial gentrification or race politics, you could feed it lists of keywords and get possibly the universe of tweets containing those keywords. So you can kind of get the best of both worlds. Yeah.
Sorry, just a clarifying question. So if I understand correctly, the hypothesis is that for people in the core of structure, all you need is simple contation, but for imperfect, you need complex contation?
No, it's that I guess I sort of like put a check mark here as well. That you don't care about the identity of the person in a simple mobilization that you learn about the thing from. It could be from the core or the periphery, because the code doesn't care that a famous person sneezes on you, right? But the reason that the core doesn't matter for complex mobilization is that there are just few of them. I mean, it's almost definitional, right? So like, you could have like AOC or Pelosi say, like, tweet or have a press conference, say we all need to go protest this policy, but that's only one person who's telling you that.
Gotcha. So the idea is like, depending on where the message comes from,
yeah,
like the contagion process behaves in different ways.
Yeah, yeah. So I'll skip over this. This is just a time series of IQs recording from Egypt, just to give some face validity to the measure of protests. And we see spikes where we expect to see spikes, and lulls where we don't. That big spike is January 28th, which is a Friday. So January 25th was a Tuesday. It was National Police Day. So that's why the first protests were then. But then the largest protests were actually about 3 days later. So I then use really simple natural language processing to measure coordination, to measure what people were saying. And what I do is I take the hashtag Gini. So I make a Gini coefficient for hashtags as opposed to for income, right? So the Gini coefficient we usually think of as measuring income inequality, and the way you would make that measure is you line people up based on the ranking of their income, with the richest person on the right and the poorest person on the left. You would then look at the CDF of that. And the more bowed out this is, the further away from perfect equality, the greater the inequality, the closer this value is to 1. But instead of lining people up and measuring their income, I line hashtags up and measure the number of times that hashtag appears per day, the number of tweets in which that hashtag appears. So if one tweet has hashtag Jan25 3 times, that counts as one appearance of the hashtag, not 3 appearances. So I'm measuring hashtag inequality. The idea being the more unequal hashtag usage is, that means the more everyone is using one particular hashtag, and the more that has a coordinating effect, because we're all talking about the same thing. So this is what it looks like for Egypt the day before that failed protest on January 18th. I also show you the 3 most common hashtags. And what you can see is the second and third most common hashtag, we're actually talking about the protest in Tunisia. Sidi Bouzid is the city in which it started. If instead you look at the day before the January 25th protest, you see it's a lot more bowed out, right? So this curve, coming bowed out more, right? More of the hashtag usage is coming from over here. If we look at the 3 most common hashtags, we now see the 2 most common are about the next day's events. There's no interpretation going on here. The computer doesn't know that Jan 25 is the next day and doesn't know what Jan 25 is. It's just identifying hashtags, and it's also really nice because you don't need any. You don't have to care about the language. This works the same for English or Arabic or Chinese or whatever. The computer doesn't care. It looks for the same Unicode characters in the background, and it sees Unicode. It doesn't see. We see printed language. It doesn't see different characters. So I get daily measures of coordination, and then to measure how much of that coordination comes from the core, I also look at the number of followers an account has. And so I get a country follower distribution, and I say if you're in the top 5% of your country's follower distribution, you're in the core. And so then I measure the percentage of hashtags per day that come from the core as opposed to coming from the periphery. And I interact that. So the core coordination measure is whatever the coordination measure is times the percentage of hashtags from the core in that day. I don't have this slide up here, but it's somewhere in the supplementary materials. One concern you may have is that because the core, by construction, has few people, they might also be responsible for just a few hashtags. But actually, the more followers one has on Twitter, generally the more engaged you are, the more you tweet, and that you can look at the tweet distribution by percentile, by where you are in the following percentile. And it varies by country, but the top 5% of Twitter users are responsible for anywhere from like 15 to 50% of tweets on average in this study. So it's not that the finding that I'm going to show you is not because I'm looking at just few people. These few people actually are responsible for a disproportionate amount of Twitter production. And I'm sure that's still true, and I'm sure that's true outside of the context of this study as well. So, there's a big regression model, and in a longer presentation I'd go into detail about it. But this is the main result. This shows you marginal effects from my negative binomial regression. And the key is this upward sloping line for peripheral coordination and the flat line for core coordination. Don't pay too much attention to the numbers on the y-axis, because these are counts of protests reported in newspapers, but notice the relative difference. There's almost a quadrupling of number of protests as we go from no coordination coming from the periphery to, I don't have any day where all the coordination comes from the periphery, but you can extrapolate past the end here. And so we see a very strong and positive correlation between coordination coming from the periphery and the size of protests on the subsequent day. This is all my IVs are lagged one day, so I'm not measuring contemporaneous events, and nothing for core coordination. It's good practice no matter the kind of data you use, right? To have a lot of robustness checks. You want to try to rule out possible confounds or biases in your data, and so I've done a lot of that here. And the stuff that I talk about here, and I'll show you in the images presentation, I think are just good practice in general if you work with social media data. So I did build a support vector machine to actually create a topic model of coordination tweets. Resource constraints is only for Bahrain and Egypt. But I can show that if you make a topic model of coordination and then count the number of coordination tweets per day, that correlates very well with the hashtag Genie that I come up. That is my main measure for coordination. So even though the measure for coordination is not really about the content of the tweet, or it's not about the valence of the tweets, it's just looking at a word, it does do, in this case, a good job of actually measuring coordination. I changed the thresholds for core so that I have it vary from the 80th percentile to the 99.9th percentile, so I know the results aren't just some noise due to making the cutoff at the 95th percentile, and I see no change, and sometimes even a negative correlation. Different sets of data for the dependent variable. I showed there's this one data set, the social conflict in Africa data set, and I showed there's some correlation between their estimate of protest size and the number of protests that IQs record. So that gives us some confidence that what I'm not doing is measuring media saliency or like media bias or novelty, but actually measuring protest size. In subsequent work, I actually have more direct measures of number of participants, but just not here. And then I drop. I should go back and look at the code and read the paper. I think I drop any protest day that is in the top quartile per country, and I think I drop Twitter countries with very high rates of Twitter penetration and very low. And I forget exactly which thresholds I used, but the point was I wanted to be sure that my results weren't being driven by just Saudi Arabia or just the UAE or something like that. Or on the other hand, noise in countries with very little Twitter penetration like Yemen or Libya. Because what I do is I aggregate everything to the country day level. So 2 tweets from Yemen in my final model count just as much as 1,000 tweets from Saudi Arabia. And so I'm confident that it's not one part of the distribution driving results. This is a pretty broad pattern. Other operationalizations for the core. There's some people did I forget exactly how they did it, but they basically identified accounts that were tweeting in Egypt and assigned them to like 10 or 12 occupational categories: celebrity, blogger, politician, athlete, that sort of thing. They shared the user ID of those accounts with me, and I looked to see if they were in our data set, so I could have a much smaller robustness check where I looked at like occupation type, and I said those people are in the core, not using the follower distribution, and I still found no result. That was only for Egypt. There was also an almost complete blackout in Egypt, but if one ISP and some major institutions still had access, and so you still get tweets from Egypt during this blackout. And so I say, okay, well, if you knew how to get access to the internet, then you're some sort of elite, right? Maybe you don't have the most followers, but you have some sort of knowledge capital or social capital to do this. And I use that to measure the core, and my results don't change. The point of me telling you all this is just to say that, just to emphasize that I think with a lot of social media work, if you're trying to make the case that you're studying real-world phenomena, that you're studying offline events, which is how I view my research, then the onus is on you to try to find other ways to convince people of the validity of your measures. I find it a little burdensome because at this point, I think it's I don't need to convince myself, but nonetheless, you have to do it to convince potential reviewers. Yeah.
So, a question. So, do you differentiate? There are different types of protests. Do you focus on, for example, on democratization protests, or there are variety of protests that you're trying to differentiate, and is the same? The same process is going on.
So there are certainly different processes depending on the kind of protest, and especially depending on like how oppressive a regime is. I did it here because those are all like mass revolutionary protests, so it's kind of controlled for by design. What I'm about to show you now, it's complete like availability bias on my part, just where there have to be protests, and I don't distinguish between the kind because I essentially only have five protests. So the short answer is I don't, but I would like to, given kind of more time. I have this like longer career goal of building an immense data set from this, and then I would start to have enough protests and enough observations, enough different countries to tease that out. But right now I don't.
And these are protests, not strikes, just kind of big democratization movements.
Well, if a strike,
France, for example,
yeah.
France, you have a bunch of different strikes, and then you have yellow west, so.
Yeah,
And there are completely different dynamics, and.
Yeah, so if it's labor unrest on its own, then yeah, I don't look at that. However, sometimes strikes occur during a larger protest wave, and that is in my data. So I was just yesterday looking that what I'm about to show you. Venezuela is one of the countries that I look at, and I was looking at some tweets, and I noticed these were like they were striking workers, like showing that they were striking. So that does show up in my data when it's part of a larger process. But no, I don't study that separately on its own. So it turns out we actually know very little bit about how large protests come to be large protests. We know they're important, but I think largely for measurement reasons, we haven't really been able to tease apart mechanisms that determine it. We have like simulation models, some lab experiments at asking people if you're more or less likely to protest based on X, Y, or Z, but we don't have large-scale observational data that's done this. Okay, I think if the state is kind of violent, protest gets larger. Very violent, protest goes down. Any protest or violence should decrease the size of protest. And previously, we just had really coarse measures. There are two different expectations for how the identity of participants should affect protest size. And so in this paper, we're just going to test those because we can measure 3 demographic traits of protesters, but we don't have any strong beliefs over which it should be. I think images should be used for data. I'll skip through this. Happy to share that paper and talk to you more about it later. So this is a high-level overview of what we did. This project is taking my geolocated tweets from a protest period, downloading any images attached to those tweets, and then identifying which of those images are protest images, and then from those protest images, extracting information. And so the first step, I'm already collecting tweets. We first have to build a classifier to recognize protest images, and then we build another classifier to measure a whole bunch of stuff in those images. Protest or violence, state violence, things like if there's fire, are there children, are people shouting, but also, most importantly, what we can learn about protesters from their faces. And so we also can measure the race. We put it into one of 7 categories. Gender, we just give 2 categories. And age is 9 bins, I believe. So not a precise number, but basically decades. It turns out so I should say this is all work done with Jungsiak Ju, who, has he come yet? I know he's speaking here.
Thursday.
Tomorrow. So soon. Anyway, this is all joint work with him. He's the computer vision guy, and that's going to inform the last few minutes of my presentation. But the point is, as we were doing this, we thought we were just going to take some pre-trained face models and use that, but it turns out that they weren't very good for the kind of work we needed to do. They basically were not very good for race or gender. They tended to be more male, and they were very high-quality images, so they weren't like social media type images. So he, along with the grad student, built a whole new face classifier that we use for this project. I'll skip over this. So the point of this slide is that we then, the classifier gives us an estimate from 0 to 1 about how likely it thinks an image is to belong to that category, whatever category we're interested in, whatever it's been trained for, right? And then we have to decide, well, what value of the classifier rating do we think is truth, right? So what value that the classifier gives us for group 100 for a large group, do we then want to say, yes, this is a large group, or no, this is not a large group? And so we go to Mechanical Turk to have people give us ground truth data on whether we think this is a large group or not, and then we can we just vary the threshold in the classifier above which we give it a 1 yes or a 0 no, and then we decide to keep whichever measure of whichever classifier output gives us 85% precision with as much recall as possible. That's the heuristic we used here, and so we do this for all of the labels that we have as well. So if the classifier thought put out a number of 0.4, we would say, well, that's not a large group. That's 0. Validating machine learning models is difficult because they're very complicated, right? We've built convolutional neural networks for this, which technically have like millions of parameters because each edge between nodes in the model is a weight and that's a parameter. So the point is you can't say that it's a sign that's causing something to be classified as protest. It's not like when you have a regression model and you can say, oh, well, this variable is driving the result, or these two variables, right? You have to kind of play with the output to figure out what's going on. And so that's what I'm showing you in these slides. So one way you can do it is to just look at images at different ranges of the rating the classifier gives out and just see if it passes the smell test. And I know you can't see this, but the point is it does. As the classifier gets more confident, if you were to look closely at this, these are clearly large groups, and these are clearly small groups. There's also this technique called gradient-weighted class activation mapping, which looks at, I think the last layer, maybe the last couple layers of your neural net, and sees which pixels contribute most to the final weighting. So like which part of the region has the most weight in a classifier's output, and then it just shades it for you. And so you can run this through a library. You give this photo, and then it gives you back this, where red is what the classifier is keen on. And so you can just look at some images to hopefully verify that your classifier is doing what it should. And so we can see for police, it's queuing on what these police. I mean, I can't tell you, is it queuing on like the vest? Is it queuing on the helmet? We're not sure, but it's not queuing on the ground. It's not queuing on the trees back there. And we do this for all of our labels. Children, there's something about a child's face that it picked up on. This is a sample image. So this isn't GradCam anymore. This is just labeling. I think we used, I don't remember what we used for this part. But anyway, labeling faces in our images and seeing if, again, what the computer thinks is going on is actually what's going on. This is from the kind of anti-corruption, the anti-president protest in South Korea, I guess 2 years ago now. And then you can also just look at the distribution of the ratings across different events, and you hope that those match up with your expectations. So here I'm showing you the 5-photo estimate of state violence across 5 different protests that we look at. We know Venezuela has been pretty violent. Hong Kong, there's actually a fair amount of violence. Couldn't find many reports about Pakistan, but the gist of it was that kind of the civilian government was kind of afraid of these large-scale nationwide protests and were kind of treating them with hands off. I was surprised to find that we have records of this much violence in Spain. Like, we know the police were a bit thuggish, especially after the referendum. I didn't expect it to be like what Venezuela would be like. But the point is, we see very low amounts of state violence in Pakistan and South Korea, which is what we expect, and higher in these 3. So that seems like a pretty good test. And then if we look at the percent of faces which are white by photo, we see Spain is almost 100%, very low for Hong Kong and South Korea, like we would expect. Venezuela is in terms of racial diversity closer to a place like the U.S. than Northeast Asia. So this doesn't surprise me either. Not quite sure what's going on with Pakistan. I think I've noticed in looking at the data a little more that the South Asian faces it doesn't seem to do too well on. All right, so this paper, the results that I'm showing you, look at these 24 cities in these 5 countries. And what I think is really interesting is to look at these last 2 columns. And so this second to last column is how many protest images I have for all the days in my data set. There are a lot of days where I have 0 protest images, you know, Tuesday or Wednesday, or I keep 2 weeks before the start of protests for those 2 weeks. So that's why this number is less than 0. But even on the days when we actually have protest images, you see it's quite common to not have a ton of protest images. I wish it were better, but I also think this is the low end of what is possible. I think you can collect a lot more images. Basically, if you were less restrictive about how you measure location. So the fact that I can even do this in these countries is kind of encouraging. I think you can only go up from here. So for the text paper, remember my outcome was actually the number of protests, even though what I'm really interested in is the size of the protest. But now using images and the faces in images, I can measure the size, I can guess the size of protest by just counting the number of faces in protest images. And so that's what we do in this paper. If we have a photo that our classifier says is a protest photo, and then there are faces, then we just count the number of faces. So this is very naive and very simple. Again, because I've been doing this for a long time now, it doesn't surprise me that it works, but it surprises a lot. A lot of reviewers are skeptical, so we've then done a lot of other work verifying this measure. So this is a working paper I have, again with Jungseok Ju. Keith Chen is at Anderson, and Anton is he just graduated from the PhD program here in Poli-Sci. But Keith has cell phone data from the U.S. We should all turn off location services, basically, is the takeaway of the slide. And so we measure the size of protests of the Women's March protests in the U.S. in 2017, and then we correlate that with, this is a newspaper measure, this isn't my data, this is an existing data set. These are all from my tweets. Images, faces is what I showed in the previous slide, is that. But then we also count the number of accounts which use one of 3 of the main Women's March hashtags, or they count the number of accounts which share a protest image. So this is counting the faces in protest images, this is counting the accounts which share a protest image. And the takeaway is that the mean error is actually quite small. So this is absolute, this is mean error. And that the vast majority of observations are within 1 standard deviation of the true size as reported by cell phones. So this is only the United States. It's really hard to get cell phone data anywhere. So I don't see anytime soon validating this in other countries. But then what we have done is we go to newspaper estimates of protest size from other countries. Right? So it turns out actually that newspapers do very well. This was surprising to me. So then we go to newspaper estimates for South Korea and Russia, and then compare those to our faces measure, and we see decent correlation. So the R squared is going to be even lower than that. I wish it were better, but the point is the lines are in the right direction. The noise is pretty normally distributed, and in fact, it's going to attenuate any results because of the noise that we have in our measure, right? But counting faces still does a pretty good job. This is what the trend in protest size looks like if you then use our measure. So earlier I showed you the trend in Egypt using newspaper articles, and this is the trend using count of faces, and it does a pretty good job of matching what we think happened in Spain and South Korea, and then elsewhere I show this for Ukraine as well. But so we see spikes where we expect to see spikes, and we don't see spikes where we don't expect to see spikes. So again, there's a whole series of regressions, and I'm just going to show you 2 of my main marginal effects. One is this monotonic correlation between protester violence and subsequent protest size. And then what I was super happy to see was this in-shape effect, or correlation between state violence and subsequent protest size. So we find evidence of backlash, but then effective repression if the violence is strong enough. All right, so just like I showed you with the Egypt data, we slice and dice this in a lot of different ways just to make sure that to try to convince ourselves that there aren't biases in the data driving the results. I think this is I think to me these data have a lot more internal validity than the text tweets I used for the Arab Spring. But nonetheless, people have a lot of concerns, and so we still jump through a lot of hoops. This is actually the model. So we do have the model now, and then these are different robustness checks. Normal users is I kept everyone in the 25th to 75th percentile of the country month follower distribution. So got rid of very popular people or very unpopular people, and we see the correlations are essentially the same, and they're the same for the violence ones, which I care about the most, and for the demographics we get changing inferences really based on the standard errors. But you don't see like anything jumping around, right? And for our main variables, we don't see we see pretty consistent, significant correlations. I dropped accounts that weren't or that are verified because they might be more likely to act strategically. Like those are going to be more likely to be politicians or elites or journalists or something like that. So I dropped that. And then I also keep only tweets that are in the country's lingua franca. So like in Spain, we keep tweets in Catalan and Spanish, but throw out anything that's in English or French, like tourists or something like that. And this is really cool. This actually produces the best model fit, and we get noticeably larger coefficients. For the Arab Spring paper, we also did the same thing and found a similar result, that our model actually fit better. So I think this is pretty cool. So it suggests that there's I don't know. People are certainly in the Arab Spring tweeting in English was kind of a strategic behavior. I'm not sure if that's what's going on in these countries, but it seems like the signal is stronger if you restrict your analysis just to tweets that people are most likely to be able to read. And then we submitted all our accounts to Botometer, got rid of them. Turns out there were very few bot accounts. One of the coolest things we did, and one of the reasons why I think images are great for event data, is because we can detect duplicates really easily. So text-based approaches like the GDELT and IQs, they've gotten better at deduplicating events, but 5 years ago, you would have thought there were like 400 Boko Haram kidnappings in Nigeria because that was a really salient event for a while. And so, if it recorded 120 protests in Egypt on January 25th, probably wasn't actually that many protests, right? But the point is, it's hard to automatically deduplicate events when it's based on text because things are described differently. They might report locations a little bit differently, like maybe the location is where the article was filed and not actually where the protest happened. But it's very easy actually to detect duplicate images and just remove them. And so that's what we do. The way we detect duplicate images is you take the last layer from your convolutional neural network. So there are going to be a whole bunch of weight estimates, and then you do a pairwise comparison for every image to each other, and so you get a distance between an image and every other image, and then you kind of look at your data set for that. I mean, if the distance is 0, then obviously it's a duplicate. But in our case, we found a large cluster of images where the distance was like less than 0.2. I have the slide in the appendix. But so the point is, you can measure the distance between images really easily, and that's how you detect duplicates. So it's like plagiarism detection for text is essentially what it is. And so we see the results don't change, and then if we actually weight it by the number of tweets per city per day, we get even stronger results. So this is basically the weighted result is like letting Venezuela and I think Caracas and I think Moscow and Barcelona had a lot of tweets per day, and so focusing more on those as opposed to giving equal weighting to like Lahore and some of the smaller cities which just had 1 or 2 tweets per day. All right, so that's that result. Any questions about that? Yeah. Hi.
I had a question about, I guess, the implications of media censorship and slanting on these findings, especially when you're using newspaper reports to validate.
Yeah. So you're concerned about censorship as people self-censoring on Twitter, or maybe if my data differs from newspaper reports, it could be because of censorship. Is that what you're?
Yeah, I mean, and you can also see the opposite as well. So I mean, it's like there could be again more of an a protest taking place than anyone ends up being able to capture, especially if there are differences in the people who actually end up participating.
Yeah, so I mean, the short answer is I don't really have a good way of accounting for that. The major international newspapers, we generally believe, do a good job of covering kind of major events in other countries because they're not subject to censorship, really, right? It's not like you're not reading Xinhua or like whatever the Venezuela like main papers, so like we trust kind of those sources. So I'm okay going to those to validate like the spikes that I see. It's certainly the case that Twitter users are not representative samples of their population. Does that mean they participate in protests at a differential rate? Or what I think is most important, do they show images from protests in a way that would be different from the other people not on Twitter there? I think that's unanswerable, or at least unanswerable with my methodologies. That cell phone data made me feel really good because even though the U.S. is kind of like a best case because we have a lot of Twitter penetration, and I don't think people are really afraid of expressing themselves online. It's still we know that Twitter's biased in the United States, and so it's still nice to see that it performed well there. But no, other than like deduplicating images, because like some people will just tweet the same thing over and over, or getting rid of bots, or getting rid of accounts based on like how popular they are. I don't have a way I don't have any better way to figure out if there's like selection bias into my data, and that's driving my results. Part of what I would like to do is not rely on just GPS coordinates like a future project, but to look at users' self-reported location in their profile, because about half of accounts have a location that is like a real-world location, so it's not the moon or my head, but Los Angeles or California or whatever. And so that would at least give me more faith that whatever I find is not due to the really small subset of Twitter users who tag their tweets with GPS coordinates. It's like 1% to 8% of tweets, depending on the country, have GPS coordinates. But I don't really have a good answer for user bias. And that's, I just need to get 3 reviewers who don't care about that as much. Trust them all the time. Because like some, that'll like throw off some papers. That's why I get rejected. Yeah.
So I think you're, when you throw out, when you compare all users to normal users, you sort of get at this, but I'm not sure you get at it completely. The kind of modal effects of, modular effects of like very prestigious people tweeting things, and of course people will retweet them, but given a lot of isomorphism and kind of media like exchange, a lot of people will like slightly plagiarize or just kind of repeat a different version of what their favorite whatever elite celebrity is. Yeah. So I'm wondering if you thought about I don't know if you thought about anything you could do about that sort of dynamic of basically some sort of SUPA violation. Some sort of the network effects of people, Yeah. So, and maybe it doesn't matter if you're not that interested in the exact content, but.
So you're saying that I could be like the finding for not core could be because
people are parroting people, prestigious people in core. It's like what they call the
like two-step in communication.
Two-step, or in psychology they call it the sleeper effect.
Yeah.
So is that something that is of concern? And maybe there's a way to deal with it. I don't know.
Yeah. So in the Arab Spring paper, I did look at retweets, and I forget what the result was, but retweets of people from the core didn't change any results. One good or bad thing with the geolocated tweets is that you can't tag a retweet. You can tag a reply, which is a retweet with a comment, but so in here I have no retweet. So if I wanted to kind of do this sleeper effect or the two-step the two-step flow model of communication or whatever, I actually couldn't really do this with these data because they don't let you see retweets. So I don't know if that makes it feel better or worse, but since in this paper I'm not really interested in kind of like information diffusion, I wasn't so worried about that. the deduplicating does at least, it basically gets rid of replies, right? Because we found about a third of images were duplicates, and so we do get rid of kind of that imitative effect, kind of that social effect, right? I'm using social media here, but like really, I'm using it because it's a data source. This paper is not really about anything network related. So by deduplicating, we feel like we get rid of that part. But I mean, plenty of people use Twitter to study specifically the kind of dynamics that you were looking at. Yeah.
So I think you mentioned that I may have misunderstood or not. How you treated tweets in different languages. So you're Catalonia, so tweets in Spanish versus tweets in Catalan versus tweets in French versus tweets in English, and their impact. Have you somehow differentiated? Because they could have different effect because it affect different communities, right? I mean, English speaker speaking.
Yeah, you know, other than restricting the subset, like here, no. Like I don't have a model where I have. Well, I mean, the full model has like tweets in all language, right. But I don't like control for the language of the tweet when I'm looking at like whether it conveys violence or not.
Because I mean, these are very different communities. They can appeal to, right? And how they can affect them and how.
Yeah. So I mean, so the idea in this paper is that like I want to know how like real world on the ground behavior affects subsequent protest behavior, and so. While like that dynamic you're describing like certainly happens, I'm more interested in just like the documentary evidence of what's happening at the protest, not as a social media component or a networking component. So I don't look at that here. I think that'd be interesting to do. Another thing I would love to do would be to weight these results by the number of followers of the account which tweets it, so to try to get at kind of more of a core periphery dynamic, but no, here I haven't considered that. Yeah.
I guess two related, kind of like relatively broad questions. I guess it wasn't quite clear to me how much of a cause claim you make. Like how much of this is sort of like documenting the correlation that is there in the world, and how much this is a causal effect. And then, so the second is just really super broad. So for the second study, for example, which I find really interesting, what's kind of like the main finding? Is that the inverse U effect, or what is it?
So your first question, I think these are all correlations. It's all observational data, and I try to construct it in certain ways so that I'm as confident in my correlations as possible. But I try to get rid of causal claims in the paper, and sometimes it slips in when I'm speaking. But I understand it's just correlation. But that said, like there are other studies which use instrumental variables or natural experiments which kind of find the same thing. So I'm okay with that. Yeah, so this is the main takeaway. So there's mixed findings in the protest literature about the effect of state repression. Some studies find that they increase protest, some find they decrease it, or some find they have no effect. And these studies, the outcome is usually like, was there protest or how many protests, 1 day, 1 week, 2 weeks later. Some use protest size, but most are just using basically an ordinal variable. And so the argument we make is that it depends on how severe the repression is. And then that's building off of people have done like lab experiments. There was one study which made an ordinal variable with 16 levels for violence, and they found kind of this U-shape as well. So we're not making a novel argument really saying that it depends on how severe the violence is. I think people kind of like understood that. But we're saying we think this is why we have this mixed finding before, and now we can measure it very well. We can give you a continuous measure of violence as opposed to mapping this continuous thing onto discrete categories on entirely different rules based off of your coding team or your sources. They're like, I think the previous approach is like I mean, that sounds bad, but like very difficult to actually do what you want to do, and images get you there. So it was unclear because I didn't dwell on that given time, but yeah, that's
And then one follow-up, so just to understand this correctly, because I think I do not, like the outcome variable means, so the size of the protest is essentially the number of faces on the photos that you have, the average number of faces on the photos that you have, irrespective of how many photos you find.
It's the sum of faces, not the average number of faces. So you said like not average per photo, but the sum of faces in all photos. Yes, irrespective
So
of...
it is not irrespective of the numbers of photos you find. So just like
Correct.
the sum of faces across all the photos you find.
That's
So
right.
it's both more photos and more faces per photo.
I mean, it could be one or the other. So we have run it where we count the number of photos instead of the number of faces per photo. You know, I think maybe then protester violence loses its significance, but state violence stays significant. That's in the appendix somewhere. I don't have results
Right.
here.
I was just wondering about the inverse view of there being two different groups. The one group sort of like identifying themselves with the protest, having few faces on the protest because they want to show that I am connected to this protest, it's me. The other kind of like more of the onlooks, like look at how many people there are, and then you get exactly this. Like in the beginning, it's interesting to show that this is a big thing, so many of these big photos, and in the end, that kind of like what's taking over is kind of people being either being prone to show that this is my identity, so you have these like few faces on the photos, and so it goes down. So it's sort of like it's what you pick up is essentially just the heterogeneous effect, as like is the relative fraction of these groups that just changes with the dynamic of the protest, and it's less sort of like the size of the
and so you're saying like the state will become more violent over the course of a protest as well.
Yeah, so in the end, it's not the state repressing the size of the protest. It's more like it's kind of like separating the wheat from the chaff, right? So like some people stay in because it's identity. Some people just don't publish photos anymore because everybody knows it's a big protest.
Yeah. So that last part is what concerns me more.
Yeah.
Or that like you're scared of identifying yourself, and so even though the protest
and
is
that's
inside,
exactly my story for like something like Russia or like you know like so you kind of like it's then you get into this problem of kind of like identifying a different dynamic in a sort of democratic state versus an authoritarian state.
Yeah.
Right. So in the end, here you have all these guys who identify themselves and show it, and in the other case, you have either nobody or just like these few onlookers who say, "Wow, it's still so big."
Yeah. No, that's all. Yeah, that's all. Those are all good points. You know, it's observational data. Yeah. Other than making the DV the number of images, protest images, we don't have like a good way of teasing that apart. Yeah.
Well, you could compare what's happening a lot with a larger sample in authoritarian countries.
Eventually,
non-authoritarian countries. But I guess like the larger concern here is it seems that image production by protesters themselves would just have a lot of variance across time, but also you know, there could be, you know, it's almost like a lot of the stuff when you think about images and how they're often used discursively, you know, in terms of semantics, in terms of, you know, people think about, there's some images that might like even motivate. So you have, it's almost, there could be some algorithmic confounding with, like, you think about image production and how certain images have moved people tremendously and also can move people to, I don't know if that presents a problem to you, the amount of images, the amount of faces. Also, you know, you make an image and there's always like a frame.
Yeah.
And only if you do a close-up, you only get so many faces.
Yeah.
If we're going to go like measure crowds, you know, we'll go take an airplane or a helicopter. And kind of, there's other ways to estimate.
Those are all good points. I'm standing in the way of you and coffee, and I want to like do this real quickly. Okay. So I'm not. I would love to engage, but I wanted to just finish this, and I'll just speak through this. Basically, the Arab Spring stuff was basically all on my own. This is with Professor Ju, who y'all will meet tomorrow, and I essentially I don't think I could have done it without finding someone who already was a computer vision expert, because like once you're a professor, you just have all these other responsibilities. It turns out. So the point is, I've done a lot of. It's bad. I've learned a lot about what it's like collaborating with someone from different disciplines. In this case, computer science. There are a lot of good things about it. They just know different things than you. I didn't have to spend time learning how to do image analysis. I've found that funders, both like internal to the university and external, tend to like interdisciplinary stuff and funding teams from different backgrounds. So we first started this project with a UCLA Big Data Transdisciplinary Seed Grant, and it was like perfect because he is computer scientists in communications, and I'm here, and so like that was really great. And so it also means that like I could apply for like an SF computer science, it's like a co-PI or something, which I would never really do on my own as a social scientist. And then because of different norms, I'll get to that in a second. Like we basically split kind of the writing, and so like everything I just showed you, I've honestly written the whole paper, and his name's going to be on, and that's fine. And we have some conference proceedings where I've done very little, and my name is going to be on it. I don't think it helps me. Those extra publications aren't in political science, so I'm not sure if that helps me on tenure, but like it's still nice to have more publications than not. Right? It is different working in a team. Part of that team is learning how to manage other people, how to manage students. And I think that'd be the case even if, I think most of the undergraduate students, even if you're like working in another team, like just learning how to communicate and divide tasks has slowed down the project more than I thought it would. But I think that's kind of true in everything. But I put this in larger font because the really big block has just been different disciplinary norms. In computer science, they do conference proceedings, which are like no more than 4,000 words, but often a lot shorter. Frankly, it's easier to get a conference proceeding accepted. There are a lot more conferences, and they're not really space constrained in the way journals are. So it's still selective, especially for the better conferences. But like even the second tier poli-sci journals are way more selective than conference proceedings, and you have to do more work for a research paper in the social sciences than in computer science. And so what that means is like we have 2 publications now that are like from him basically that my name is on because it's a smaller unit, and he's like, hey Zach, like what's going on? It's been 3 years. Why don't you have anything for me? But it's like I'm like I've done a lot of work in 3 years. Come on. And so they also have much stronger norms in computer science and probably other fields about authorship, your name on a paper, which like I'm mentioning this because we've had many conversations about it. And what I'm learning now is that like you want to be first or last, and I guess like if you're the head of the lab, you're last. And then they run on a lab model. So Jungsiak is mainly fundraising and identifying and bringing in students. And he's much more of a manager more quickly than I am. And I didn't like, I see political scientists who do that, and they're like 10, 15, 20 years into their career. They're not fresh out. But people from where he comes from, you have a lab right away. And like he literally has, a room with some graduate students. And so that means one reason I've done a lot more of the authoring is because he's identified the students. And so Alex Chan, who's done most of the image work, is someone that Jungsiak recruited, and it's been very good, and he's better at finding those people than I could be. So it's a fine division of labor. I'm not complaining that I've done the writing on the image paper, but that's just what it looks like with their different backgrounds. I do think though that if you're just starting out, I wouldn't like the kind of the barriers. Like not being familiar with how to do a convolutional neural network, like stop you from learning it. Like you do have time. I think the way that I did my own text analysis, you could develop your own image analysis, especially because there are well documented libraries now. Definitely in Python, I think in R, but again, it's a much bigger community in Python, so it would just be better to do it in Python. So the point is, like, I don't think you have to see what I presented and say, oh, I have to go find a computer science grad student. Because that's actually not going to be productive for you, because that student's going to be thinking of industry or a comp sci job and might not be interested in social science questions. But someone at my stage, I think you do need to have a collaborator. And when you identify that person, y'all need to like go through these norms. So Jungsiak and I did talk about like how the unit is longer. I said I need to publish in poli-sci journals, and we're doing all that. So I think it's going to be fine. But I did not realize the gulf in norms, and I don't think he did either. He was also a new professor, so that's led to some friction. I thought he had already spoken when I prepared all this, so now it's like I'm all the gossip. Also, so this is not about collaboration, but this is stuff that I wish I knew before I kind of started doing big projects. And I think this would be true even if you're not doing like a heavy programming project. But you should have a directory where your paper is in. These are the 4 subdirectories that I use. I then have a README file that says those following things. It tells me what data I use so that are in the data file, and then what each script does, and then in the README file it has this information as well. So when I did the Arab Spring paper and then I had to like submit everything, I didn't have a README file. My scripts weren't numbered. It took me days, just to figure out what I had done, frankly. Like you go to this script, you see what it takes, you step backwards, and it gets really messy. Having this README file that you update as you go along makes picking up a project later much easier. It makes showing it to other people much easier as well. I've also learned, scripts, you should start with, the name should start with a number, not a descriptive name. So it used to be like read tweets and then make model. But now I do 01 underscore retweets, 02 underscore make model. And the numbers, of course, correspond to like where in the pipeline for your paper it goes. So it's much easier to figure out how everything fits together when you start naming them with numbers. For version control, I just add to the file, underscore v some number. Some people will use GitHub for this. I know there are a lot of other versioning software available. I don't. That's another tool. I'm lazy. That's another tool I don't want to learn. Pablo Barbera is a methodologist, and so he has a nice presentation on some other best practices, and so that's what this link is. But basically, this slide is saying like be organized. It's worth the investment up front to keep your project organized from the get-go. All right, thanks.